we're going to talk about phase shift, understanding phase shift, and what this means as a horizontal translation. All right, so we've seen our trigonometric functions a couple of different ways, a couple of different times. In this one, we're going to look at it as the phase shift. So the phase shift, we're going to have an equation, y equals sine of x minus h, where this h piece, this horizontal translation, this horizontal shift, is going to be our phase shift. Phase shift. And if we remember our graph, so let me get my straight edge here so I could draw out the graph. If we remember the graph, let's say a sine function. This is the same for a cosine function, that h would be a horizontal shift, which in our case would be the phase shift. All right, so if we're looking at a normal sine wave, that didn't come out too bad. We have the amplitudes at 1 and -1. We have our peaks and our valleys at 1, -1. Our midline is at y equals 0. We start here at 0. We end here at 2 pi. All right, so what the phase shift does is it moves this whole graph over. So let's say I had something like, I don't know, y equals sine of x minus pi over 4. No, you know what, I'm going to go with pi over 2 because it's a little bit easier to see. So pi over 2 is going to be this max piece here. Extend this line, it's not going to be the straightest line. Maybe I should get my straight edge back, extend this line a little bit more. All right. And then we're going to end here at a period, because we're still doing the same period. It's still the same up and down, a period of 2 pi. It's just that we're shifting things over by pi over 2. So this point right here is shifted over by pi over 2. This point right here is shifted over by pi over 2. This point right here is shifted over by pi over 2. And we essentially have a phase shift. All right, so the phase shift is technically the horizontal translation of a periodic function. So let's write that out. The horizontal phase shift is the horizontal translation. I like how I put a space between horizontal and translation of a periodic function There you go. So phase shift is the horizontal translation of a periodic function. Right, so let's look at another piece of this because we're looking at horizontal translation. So how does changing the graph? So let's say I have the graph y equals sine of 2 x minus h, x minus pi over 2. Let's use that pi over 2. So for each transform graph, the amplitude is still 1. The period in this case, because now we're looking at this guy right here. Remember this guy right here, that's not the best color for black, and I always choose that color. This guy right here, remember, it helps us with a period. So our period is going to equal 2 pi divided by this value, which is 2, which now equals pi. So again, let's get my straight edge here. Let's look at what this looks graphically. Turn this 90 degrees. Okay, so our original function would look something like this being 2 pi. The new period, make sure everything ends by pi. So I'm just going to chunk those in half. Maximum, minimum, I like how I go a little bit further than that minimum there. Minimum, up, down here, and this is a pi. And then our phase shift comes into play. Now we're moving my graph over by pi over 2. Or my phase shift. So this right here is pi over 2. That means this point right here becomes the beginning here. So we just moved it pi over 2. We're going to move this guy over pi over 2, which is here roughly. This one originally is going to be moved over pi over 2. And this one's going to be moved over pi over 2, so roughly about there. And then pi over 2. Okay, so we're still looking at this kind of shift by pi over 2. We're just now looking at a period that's smaller. We're looking at a compressed graph because of that too. All right. So let's put a couple of these pieces together. Let's say we're looking at the function y equals 3 cosine, let's look at a cosine, x plus pi over 4. All right, now we're looking at an amplitude and a phase shift. So again, get my graph. Cosine starts at 1, at pi over 2 goes to 0, at pi goes to negative 1, 3 pi over 2 goes to 0, and 2 pi goes to 1. So we still, that's not a 1, that's a little bit higher. So we still have this wave function. It's just honestly a phase shift from sine, and I believe it's over by pi over 2 to the left. All right, so now let's see what we're looking at here. So we're looking at a new amplitude, and I should have drawn this a little bit higher, but we're looking at an amplitude of 3. So we're looking at an amplitude here and here. So we're going to start here. We're still going to go through 0, go down to 3, 0, and up to 3. So we've kind of just pulled this cosine graph up. We've pulled this cosine graph up to 3. Okay, now our period is 1. We don't have anything. Our period's still going to be 2 pi, so we're still going to effectively be the length of 2 pi. All right, now my translation is moved back by pi over 4. So if I'm going to draw this, I have to look at moving this to the left. Let's say this is pi over 4. Because if this is pi over 2, this would be pi over 4. So each of these, let me choose a different color. I'm going to choose this pink color. This would move back by a length of pi over 4. This would move back by a length of pi over 4. This would move back by a length of pi over 4. This would move back a length of pi over 4. And this would move back a length of pi over 4. And you would have something like the pink line. Alright guys, so there's a couple of examples of this phase shift. The phase shift is basically taking the periodic function and moving it left or right. It's just that shift that we've seen before, that horizontal shift. But again, if you have any questions, always feel free to reach out to me, and I will catch you in the next video.